This is a video about factoring trinomials when a is not equal to 1. There are many methods to do this, and so this is called a trial and error method. So first, let's look at an example. We have the following problem: 2x squared plus 9x plus 7. So we need to factor this. Now, we need to come up with two factors that will multiply together to get this trinomial. One of the factors will start off with 2, and the reason is because 2x times x will need to equal 2x squared, and this is the only way that that can happen. The only other way is if this is x and this is 2x, but that's the same difference. If we look at our signs, the second sign is positive, which means that both will be the same, and the first sign is positive, so that means that they're both positive. So we've got this thus far. So now we need to find the factors of 7. Because 7 is a prime number, its only factors are 1 and 7. So I need to put 1 and 7 in places to try to make this FOIL out to be 2x squared plus 9x plus 7. It's probably not a good idea to put a 7 here. And the reason is because if I put 7 here and 1 here, and I try to FOIL this out, at first I'm going to get 2x squared, so everything looks good. When I multiply this times this, I'm going to get 14x. And when I multiply this times this, I'm going to get 1x. And of course, it started off with 2x squared. And then at last, I'm going to get 7. So the first and the last look good. But inside here, this combines to get 15x. And that's not 9x, so that's not what we want. So let's try it again. The only other possibility could have been plus 7. Now notice, by putting the 7 with the 2, we don't actually have to multiply those two numbers and get something that's really large. So 2x times x is 2x squared. 2x times 1 is 2x. 7 times x is 7x. And 7 times 1 is 7. So now when I combine these middle terms, I get 2x squared plus 9x plus 7. And so that checks with what I started with, so this is the right answer. And so that's why we call this a trial and error method, because we're just trying to find it. Some helpful tips are that 70% of the time, the factors that work are the ones that are closest together. So to look at what we mean, let's look at an example. If we have 5x squared minus 13x plus 6, what we mean is one is going to have to be 5x and the other is going to be x, and that reason is because 5 is prime, so 5x times x is 5x squared. For the last part, we have to get 6. So the possibilities are 1 and 6 and 2 and 3. 2 and 3 are closer together than 1 and 6. So that's what we mean. Let's try these first and see if they work. They're not always right, but let's try those first. So let's just try a 3 here and a 2 here. And this says that they both are going to be the same, and then this one says that they're both negative. So let's try this. So if we FOIL this out, we get 5x squared. 5x times negative 3 is negative 15x. We multiply these together, we get minus 2x. If we multiply those, we get 6. So this ends up being minus 17, so that's not right. So let's try them switched. So let's try 5x minus 3 and 5x minus 2. I'm sorry, not 5x, just x minus 2. So if we FOIL this out, we get 5x squared. 5x times negative 2 is negative 10x. Negative 3 times x is minus 3x. And then minus 3 times minus 2 is plus 6. And then this sum will be negative 13. So this looks good. So this checks, so that means that this is our right answer. Now, were we sure that the answer didn't involve the 1 and the 6? No, we weren't sure, but 70% of the time it will work out to where the factors that we want to use are the ones that are closest together. So we just try those first. It won't always work, but it's a good start. Another helpful tip is that if there's not a GCF at the beginning of the problem, then there can't be one in the factors. Let's look at this as an example. Here we want our factors to be 2x and x. Okay. As far as 4 is concerned, the factors are 1 and 4, or 2 and 2. Now if we tried 2 and 2, a 2 would go here and a 2 would go here. But if a 2 goes here, then there's a greatest common factor here, which means a 2 could come out of the problem, but there wasn't a 2 that was able to be factored out at the very beginning. So that can't be. So it must be the fact that we have 4 and 1, so this would be an exception to that 70% rule. Although we've only looked at 2 and it's been wrong half the time, that's not in general the case. So now we have to figure out what we're going to do with our signs. This sign says that they're both different, and this sign says the bigger would be negative, but we don't know which one would be bigger in this case. So let's just try a plus and a minus. I forgot to put an x there. So if we multiply these out, we get 2x times x is 2x squared. And then 2x times negative 4 would be minus 8x. And then this would be plus x. And then this would be minus 4. So minus 8 in x is minus 7x. So this looks good. It looks like it'll check. Now if my signs hadn't worked, I would just try the other one and go about it that way. Okay, let's look at another example. Now in this case, my first leading coefficient is not a prime number, so that means we could end up having 15 and 1. So it could be a case where it's like 15x and x. But let's try instead the case where it's 3x and 5x. Okay, and the reason is because again that would make my factors closer together. Okay, so I mean because 15 and 1 are further apart than 3 and 5, so let's just try it this way. Now if we take 6, our factors are 1 and 6 and 2 and 3. 3 obviously can't go here because then there would be a greatest common factor. For that same reason, 6 could not go here. So I'm either going to have to put a 1 here or a 2 here. Let's try the one where the factors are closer together. So I'll put a 2 there and a 3 here. And then I'm just going to randomly put my signs in. Okay, I mean I know of course that they both have to be different. So I'll put a plus here and a minus there. And then let's just try it. So that's, if we FOIL that out, that's 15x squared, 3x minus 3, or 3x times negative 3 is negative 9x, and 2 times 5x is 10x, and then 2 times negative 3 is minus 6. So this looks like it would be plus x. So let's try to switch the signs because it was close. So if I switch them and I multiply 3x times 5x, I'm going to get 15x squared. 3x times 3 is plus 9x. Negative 2 times 5 is minus 10x. And minus 2 times 3 is minus 6. So now this will be 15x squared minus x minus 6, and that's what I started with. So that means that this is the right answer. Okay, let's try this one. So I'll try 2x and x, because 2x times x would be 2x squared. Two numbers, as far as 25 is concerned, it's either 1 and 25 or it's 5 and 5. And so we'll try 5 and 5 because they're the ones that are closer together to just try it. Here we have a minus sign, so we know they have to differ. So let's just throw in a plus and a minus. And if it's not right, we'll try to switch them. So 2x times x is 2x squared. 2x times negative 5 is minus 10x. And then here we have plus 5x, and then we get minus 25. When we combine these middle terms, we're going to have negative 5x, so that's wrong. So let's try to switch them as far as the signs are concerned. So 2x times x is 2x squared. 2x times 5 is 10x, and then minus 5x, and then minus 25. So again here this becomes 2x squared plus 5x minus 25, and that's what we started with. So that's the right answer. Okay, let's look at another example. So in this case, we'll try 7x and x. So there's different combinations for 12. Could be 1 and 12, 2 and 6, 3 and 4. Let's try 3 and 4 first. Okay, this sign says that they're both the same, and this sign says that they're both going to be negative. So if we FOIL it out, we get 7x squared minus 28x minus 3x, so that's going to be way too big, so we don't need to finish because that's not going to work. Let's try the other way. So let's try putting the 4 with the 7. Okay, here this won't work either because it's minus 25. So in this case, those will not work. Even though they work closer, it doesn't always work. So we'll just try the next closer pair. Okay, and they both have to be minus signs because, again, the second sign is positive, so they both have to be the same, and then the first sign is negative, so that means that they're both negative. So 7x times x would be 7x squared, and this would be differ by 42. So yeah, so this would be way too big. So let's try to switch them. And again, just like we talked about at the beginning, we could have seen that negative 6, putting the 6 over here in this position would not be a great idea because it would be so large. So 7x times x is 7x squared. 7x times minus 2 is negative 14x, and then negative 6 times x is negative 6x, and then this is 12, and then that will add together to get 20. So that checks. So then that's our answer. Some pros and cons. Usually it's the quickest method when you get good at it. It's definitely quick to try those first few. Oftentimes those will work. Potentially it could be the slowest method if you don't come up with smart things to guess with and if you're out of practice. It's definitely recommended when the leading coefficient for your trinomial is prime, so like 3x squared plus whatever, or 7x squared plus whatever, etc. And lastly, you would want to do a lot of practice, and that's with any method. You would definitely want to look at a lot of different practice problems.